Here we are in section 4.2 with 37 through 41. So 37, we are still subtracting polynomials, so let's make sure that that guy gets jumped in. So this is a negative, negative, and negative. So when we put those two together, we have a 5x to the fourth minus 4x to the fourth. That's x to the fourth. Then we have a negative x cubed and a negative 4x cubed. So that would be a negative 5x cubed. 3x squared, no x squared's over there, so that guy just sticks around, 3x squared. And then, here's our next one, the negative x, and then a minus 5. Interesting, not that guy, or that guy had a partner to add to, so we just write them down. And descending order is standard, though it's not always necessary. The next one, negative, jumps in here, makes that a plus, jumps in there, makes that a plus, and jumps in there and makes that a negative. So when we put them all together, we get, let me see, x squared plus x squared, that's 2x squareds. Now we have plus x plus 2x, that's plus 3x. And then 1 minus 3, that's a negative 2. There we go. Now, number 39. Ooh, interesting instructions. Find a polynomial that describes the perimeter of these shapes. Now remember, peri means around, and meter means measure. So perimeter just means the distance around something. So if we were to do this, we'd have to go here, here. Here's another one down here, 4s squared plus s minus 15. And then this is 3s plus 2. Or if you didn't want to add all those up individually, if you remember the perimeter of a rectangle, we would do, it's 2 of these plus 2 of those, 2 widths and 2 lengths. So that gives us 8s squared plus 2s minus 30 plus 6s plus 4. Can we combine any of those terms together? Indeed we can. The 8s squared is by itself, but we have a 2s and a 6s, gives us an 8s. And then minus 30 plus 4 is a minus 26. So whatever s is, that is the polynomial that represents its perimeter there. Ooh, this one's going to be a little bit unique. We don't have a formula. We just have to start adding them up. Go all the way around and add and add and add up. Okay, so let's do it. Let's look at all the t squareds we have. T squared plus t squared. It gives us 2t squared, adding all the way around. Let's do the r's. There's an r plus an r is 2r, 3r, and 3r, that's 6r, if I'm not mistaken. Good. I forgot the squared there. 2t squared plus 6r. Now let's look at the 1. Here we go. Let's do it in a different color so we can see it. Here are the numbers. So we should have a plus 4 there. And then, is there something we haven't connected? Oh, the t. Adding up, we just get a t here. So we could rewrite this and say, let's do 2t squared plus t plus 6r plus 4 in descending order if we wanted to, but that's good right there. Okay, now look at this. Number 41, look at where this is pulling from. Oh my word, are we trying to insult your intelligence? Heavens no. But notice what we did back there. This one matched up, and this was the distributive property. Notice that we're doing this all the time now. Distributing here and distributing the negative. This distributive property has come back. Next one. This right here, being able to take this and switch places here and switch places here, this is fundamental to a polynomial being able to be written this way or in descending order. So this commutative property of addition is very important. And then the associative, this happens when we have a monomial times a monomial, that it turns out you can move these around any way you want to. And so that is going to help us when we start multiplying polynomials together. All of these will indeed, hence the preparation in it. Good.